Hey folks, in the previous session we have touched upon what exactly the fuzz ratio and how to find a similarity score if I will consider this fuzz ratio metric. And we have also find the fuzz ratio or the simple fuzz ratio between these two strings, which is all about the data of zeroth index of question 1 and question 2 feature. Now in this session our cool challenge is all about the second metric, which is all about the fuzz partial ratio. Again, we will just touch upon this metric in a couple of seconds, but first let's try to compute the fuzz ratio value with respect to each of the function that you have. Again, as you have to find this ratio value or fuzz ratio value with respect to each of the observation, so why not just create some function for this? So what I will do is I will say cool, let's define a function. Imagine fuzz underscore ratio. And in the moment I will pass some row or some observation to it, I will say just return some value. I will say fuzz dot ratio, and I have to just pass some row of question 1, and along with that we have to also pass something known as row of question 2. Cool. Whatever value it will return, just return it. Cool. Let me execute this line of code. Now again, for those of you who do not have good specifications, instead of working on this entire data, what you guys can do is you can work on some sample of data. Again, this is especially for those who do not have good specifications PC or laptop. So I will say, hey, can I consider some sample, let's say of 10,000 data points or 10k data points. Hey, can I consider some sample and let's try to perform this string matching on top of this sample. So let's try to do all the stuffs. So what I will do is first and foremost, let's try to create a sample. So I will say sample is all about 0 to let's say 10,000. Cool. Let me store this in let's say df. Let me execute this kind of code. The moment I will say df.shape, now you will encounter you have 10,000 observation in this df. Cool. If I will call let's say head, let me pass a value 2. Now you will see these are the first 2 observations that I have. Now let's try to apply this fuzz underscore ratio function on top of this df data frame. So what I will do is, so I will say df dot apply. Now what we have to apply? We have to apply this function. Again, as we have to apply this function on top of each and every observation of question 1 and question 2, hence we have to pass x is equals to 1, because x is equals to 1 basically means we have to apply this fuzz underscore ratio function on top of our question 1 and question 2 feature in a horizontal way. Let's try to do this. The moment I will execute this line of code, you will end up getting all these fuzz ratio value. Now let's try to store these values somewhere else or in some feature. I will say first and foremost I have to define that feature. Let's try to define it. So I will say fuzz underscore ratio. Cool. Let me execute this line of code. The moment I say let's say df.head, let me pass some random value, let's say 2. And if again I will execute this line of code, now you will see there is a feature as fuzz ratio and you will encounter some value over here. Cool. Now let's go ahead with this another metric which is all about fuzz partial ratio. Again, before going ahead in this metric, let's try to understand some disadvantage of this fuzz ratio. So the moment I say, let's say I have a string 1 as let's say Yankees, which is of course a baseball team, or you can say it is a sports team of US. It is a sports team of US. Similarly, let's say I have a string 2 as let's say New York Yankees. Let's say New York Yankees. So the moment I say this, how similar both string are, the moment I will ask this question, and if I will say, hey, can I use a fuzz ratio over here? But unfortunately, fuzz ratio will return some low value because we have to perform lot of operation or we have to perform lot of edits on top of this S1 string. just to generate this S2, or I will say just to generate this S2 from S1, you need a lot of edits. Hence, you might end up getting a low fuzz ratio value. But from the human perspective, we know that Yankees and New York Yankees, which are the sports team, both are same. But unfortunately, this fuzz ratio returns some low value. That's a drawback. Again, for those of you who are from Asia, might not relate this concept. So let's try to explain the concept in much more layman way. Again, for those of you who are from India, there is an amazing cricket league, often known as Indian Premier League, where probably we have 10 plus team. So there is one of the most famous team, which is of course known as Chennai Super Kings. This is often known as Chennai Super Kings. This is often known as Chennai Super Kings or CSK. Of course, at some instances, it is also known as Super Kings. It is also known as Super Kings. And the moment I say, hey, just find how similar this S1 and how similar S1 and S2 are. And the moment I will use this fuzz ratio, unfortunately, we will end up getting some low value. That's a drawback of this fuzz ratio. So here comes the interesting metric, which is all about our partial fuzz ratio, So let's try to touch upon this metric. Again, main problem with this fuzz ratio is it is not able to solve the partial string similarity. Hence where my partial fuzz ratio comes into picture. So this partial fuzz ratio says, if I can partially match my string, we will recommend or we will return the high value. Now you will encounter, this is a partial string that you might figure out in this S2. This is a partial string. So the core idea behind this is, as long as the match is partial but perfect, hence it will end up getting a higher fuzz partial ratio value. So if I will say, hey, what is the fuzz partial ratio value of this? So it says, hey, as a partial match or as a match is partial but perfect, hence the value might be close to 100 or even 100. That's what actually my partial fuzz ratio says. So let's try to code up all the stuff, of course, Python. Again, just to find the partial value or partial fuzz ratio value, you have to call something known as partial underscore ratio instead of calling ratio. Let's remove it. The moment I will execute this line of code, now you will end up getting a value as 100. Cool. Now let's try to define a function for this partial ratio. Let's try to define that. So what I will do is I will say, let's say function name is all about. Or I can paste this entire code. Let's try to modify it. So I will say it is all about fuzz underscore partial underscore ratio. Here I can think of calling partial along with the ratio. I will say it is all about partial underscore ratio. Cool. Now the moment I will execute this line of code, similar stuff, nothing fancy. Then let's try to copy the entire code and let's try to paste this and let's try to modify this code. First and foremost, let's try to modify the function name that we have to apply, which is all about fuzz underscore partial ratio. Whatever value it will return us, let's try to store it. So I will say, hey, can I store this in my fuzz underscore partial underscore ratio? The moment I will execute this line of code, let me execute it using Alt plus Enter. So if I will say df of head, let me pass some value, let's say 10. The moment I will execute this line of code and the moment I will scroll it to right, now look at the difference that I am getting. The fuzz ratio value is 93, but the fuzz partial ratio value is 100. Now look at the differences that I am getting. This is just on account of my fuzz partial ratio. But again, there can be some instances where our fuzz partial ratio is unable to return a good similarity value. Hence, over there we have to consider some other metric. Again, in the upcoming session, we will try to consider some other metric as well. So that's all about this session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.